We might have all been hearing about ReasonML as this new language coming out of Facebook, developed by Jordan Walk of React fame, like one of the initial sort of contributors or creators of React. But we don't all have a greenfield project that we can sort of start writing Reason in. So can we integrate ReasonML into one of our own projects? And hopefully you'll find that it's easier than you might think. So to talk a bit about that, please welcome me. Thank you so much. Great to be here. OK, so we don't have much time. There's obviously a huge amount to cover in this topic, and we're not going to cover it all. Definitely not. And we also don't have a huge amount of time to cover like what Reason is. So one of my old colleagues, Marcel, gave a talk about Reason last month, maybe the month before, and kind of gave an overview. Hopefully you saw that. But to give a quick overview, Reason is this language coming out of Facebook. It's a dialect on top of the systems language, OCaml, which has been around 10 years or so, something like that. Just to make, it adds some features, and it makes the syntax a bit more readable and a bit more friendly to people like, I think, most of us who are sort of JavaScript developers. And either OCaml or Reason, sorry, can be compiled by a library called Bucklescript, which is made by Bloomberg. It's a really awesome library down to JavaScript. So Reason can actually be used either compiled natively or compiled to JavaScript. And both Reason and OCaml behind the scenes share the same AST, so they're kind of interchangeable in that sense. But Bucklescript's an amazing tool, and it's the one we'll be focusing on right now because this is a React meetup, obviously. So there's a bunch of features of Reason that we should be interested about, and this is just a kind of a small handful. It's a functional language. In fact, it's the only language I can think of, and I'm sure you guys in the questions will completely prove me wrong, that is functional, strongly typed, and can be compiled to anywhere. Off the top of my head, I can't think of any others. And the type system is also inferred, so you don't need to annotate every single one of your types. It will try and figure it out for you if it can. It has algebraic data types built in, which we'll look into a bit more later, which are incredibly powerful. And coupled with that, it has a pattern matching system that goes really well with these algebraic data types, which gives you some patterns in the language that are very powerful for your application. So like I said, this is a talk about integrating ReasonML into an existing project. So in order to do this, I created a quick demo project in ES6. It's a Hacker News app because they don't pay me to have an imagination. And it looks a bit like this, so I'm also not a designer. That will do. So it's made up of a list of links that are fetched over an API and a header, right? And the directory structure looks a bit like this. So hopefully directory structure is pretty familiar to you. It's a pretty standard React app. It uses ES6 and stage 0 niceness. So it's got a Babel config, and it's bundled by Webpack. Obviously a package JSON. It's a Node app. And inside the source folder is some things that you should find pretty familiar, just sort of a JavaScript entry point, some components, one of them which is written in Reason, which didn't even make it in the cut for this talk, so we might not even see it. But hopefully fairly familiar. So if you've got an ES6 app, the first step that you'll want to do in order to sort of make it compatible with ReasonML that I had to do for this project is actually only a couple of pretty simple things. So as a development dependency, you're going to want the BS-platform or Bucklescript platform. It really amuses me, obviously, that all these things start with BS. And obviously, if it's a React app, you're going to want Reason React as a production dependency in your app. And then you're kind of ready to go. Like, that's all you really need. So back in our directory tree, there's one unfamiliar file that you might have seen, which is bsconfig.json. which we can have a quick look at. That was the magic move transition in Keynote, by the way, in case you want to know for later on. And actually, the Bucklescript config is pretty simple. You can look it up in documentation online. It just tells the Bucklescript compiler where your source files are, where to dump the compiled JavaScript if you're using ES6, and some reason-specific dependencies. But like I say, it's all up there online. It leads me to actually one of the sort of purposes I want to give this talk for is not to just regurgitate documentation. So there's lots of things we'll kind of skim over because you can just read it up on the documentation. My goal for this talk is to kind of hopefully inspire some of you to just go and pick up Reason because it is hopefully easier to integrate than you think and can give you a lot of benefits. Inside the package JSON, all we really need to do is split our build step into two. So you can see on our start script, we've got a Webpack watch, which is pretty standard. But what we want to run in a sort of separate tab in our terminal or whatever is the watch script of BSB make world, which is just the Bucklescript compiler is going to find any Reason or OCaml files that we've got, is going to convert them to JavaScript, jump them in a file, and then Webpack is going to take it from there and create a bundle for us. So if we have a quick look around this, this React app, this is the index file, hopefully pretty simple and familiar to everybody. We're using Redux. We're using React Redux to give a provider. Again, just trying to find like a setup that is fairly representative of projects you guys might have already. And it's using Redux Thunk as a async middleware, I think because we're all pretty familiar with Redux Thunk. If we have a look at the actions, there are two actions in this app. We've got request top stories and receive top stories. Request top stories will be used to show a loading spinner while we're getting the stories. So you can see that that is just an action that's fired off with no payload. Receive top stories is going to take that back from the API, the data back from the API, and send it off to our reducers. And then our async function of get top stories is just going to send off request action, so, call the API, get the data back, send that back to a reducer. So obviously, very, very simple. If we have a quick look at our reducer, again, nice and simple. We've got an initial state with an array of stories. We've got a loaded flag to show a loading spinner or whatever. Pretty standard for a reducer. We're going to return an initial state if there is the state is undefined on the initialization step, and then there are two actions that we're handling, sending the loaded flag to false, making sure it's false if we are requesting from the API, and storing the stories when we get them back. And if we don't recognize any actions, then we're just going to return the state back and not do anything from this reducer. So what we're going to do in this talk is convert this file to Reason. This is actually a slightly strange example to pick because ReasonML, you might know, is actually incorporating a Redux-style reducer system right into Reason React. So if you were to build a purely ReasonML React app, you might not actually use the Redux library or the Reason version of it. You might be able to do all of your kind of Reason-style async data handling and all that kind of stuff directly into Reason React. But this is a talk about current projects, right? And after some experimentation, I kind of found that a reducer might be a good place to start if you're going to introduce Reason into your applications, because you can start to put a lot of safety into that file using the features of Reason, which we're going to see. So we're going to convert this file. Obviously, a good place to start is the initial state. That's pretty simple. And on a side note, if I'm converting a file over to Reason, there's a few things I would do. So first of all, the obvious thing is take the tests that you're using for this file and point them to your new Reason file and have them fail and iterate until they pass. That's always useful. And in my editor, I will probably open the original JavaScript file on the left, the reason file I'm writing in the middle, and then on the right, the outputted JavaScript from the Bucklescript compiler, which is easy to find. That will be dumped in the lib folder. I forgot to mention, bundled outputs will be the Webpack bundle. Lib will contain all of the reason output, those JavaScript files. So you can just open one of those up and see what reason is doing when it compiles your files. And then, especially if you're not familiar with the reason syntax, you can kind of see whether the thing that's being compiled looks anything like the thing that you used to have. And it can be a bit of a guide for you. So let's get started. Hopefully this isn't too small. I know it is small. Obviously, I couldn't have 3 columns, otherwise it would be way, way too small. But we can start with the initial state. So we think it should be pretty obvious that we can use this object syntax to define the initial state like we did before. This is actually in Reason called a record rather than an object. And that seems quite reasonable. But if we do this, the compiler is going to complain. Any record that we use in Reason needs to be annotated with a type. It's not going to try and infer a record, which it would do for other things. So to annotate this with a type, TypeScripters of us will be familiar with something like this. We're going to annotate a single story. In this case, we've got an ID, title, URL. And then the state itself, the story is going to be the stories array is going to be a list of stories. And then the loaded flag is going to be a Boolean. Pretty simple. And now our compiler is going to let us through. But you can see here that the output JavaScript file is probably not quite what we expect. We've got an array of 2 integers. And this is because the inbuilt data structures into Reason are actually very highly optimized. And not perhaps very compatible with the JavaScript that we want to be running. So this is because I think if you're doing a lot of operations, array lookups by index are much, much faster than key lookups in an object. So behind the scenes, ReasonML uses array lookups. But luckily, we have some different types for JavaScript interrupts. So we'll need to annotate our types and our objects slightly differently. The story can stay the same. Actually, it's not entirely necessary for it to be there, because we're not, in this reducer, going to be accessing any of the properties in the story, but we'll leave it there for now. And to show that this is a JavaScript type, we use the js.t type, which is provided by Bucklescript. So it's not native to the Reason language. We'll see a lot of stuff provided by Bucklescript to aid in JS interop later on. And any type can take, well, not any type, a lot of types can take an argument to sort of modify them to keep them polymorphic. The js.t type just takes a JavaScript object of the shape of the type you want to describe. And to describe a JavaScript object type, we just use the same syntax, but with a dot in front of that first bracket. And then for the initial state, we want to show, we want a normal JavaScript object, right? And that is annotated in Reason with just quotes around each of your keys. There's a bit of syntactic sugar there, which is a Bucklescript shortcut. And rather than a list, which was that weird indexes in an array thing, we use bars inside of a square bracket syntax, and then we're going to get a normal array. And also js.true or js.false and js.boolean for our Boolean types in JavaScript. And then, once we've done that, we can see on the right-hand side that we've got a output that looks a bit more familiar. So moving on to the next step of our reducer file, let's create the reducer function and handle a couple of actions. So first of all, we're going to want the function itself. That's pretty easy. Let reducer state action. You'll notice, obviously, in ReasonML, functions are defined and called without parentheses or commas. Side note, this is actually changing really soon. So if you find this syntax a bit unfamiliar, a bit hard to read, which I definitely did starting off, because we're all used to a lot more punctuation in JavaScript, Reason's actually changing to be a bit more JavaScript-like and have the parentheses and commas in our function definitions and calls. So it's going to be a lot more familiar to most of us in the room. I'd probably expect that in a couple of weeks. But for now, This is how functions are defined. That's pretty easy. Switch statements are defined in a fairly familiar way, apart from this action #_ type that we've got. Rather than a dot to access a value in an object, a dot is only used to access a value inside of a reason record, and we have to use a special syntax to access a value in a JavaScript type. These are different in that a reason record is immutable by default. It's of a fixed size. It can't change. It can't deviate from the type that you've defined of it. A JavaScript object in reason is a bit more fluid, a bit more mutable, and we use a special syntax. So ## or ##, whatever you want to call it, is how we access a value in a JavaScript object in reason. The reason why we've got an underscore before type is because type is a reserved word. So this is a shortcut in Bucklescript for using the word type. Otherwise, in standard reason, we wouldn't need this, or we wouldn't write type at all. And then we can handle our actions. So we'll start off with just the strings themselves. If we're looking at requests, top stories, we've got an empty stories array. Loaded is false, obviously the opposite for receive. We use that hash syntax again to access from the payload, and we're going to return true for loaded. So pretty simple, and you can see that the output on the right-hand side is looking pretty familiar. Not much effort, we're almost there. If we were, no, actually, so we have not covered one case, which is the kind of the fall-through of the switch statement, and thankfully, the compiler is going to warn us about this. It's going to highlight the syntax that we just put in. You forgot to handle a possible value here, for example, empty quotes. If we put in a case to handle empty string, the compiler will then say, you forgot to handle a possible case here, for example, quotes with one character in it, and it will keep going until you drive yourself insane. So one of the ways you can avoid this is with an underscore, which I understand is probably a bit hard to see there. So you can match against underscore, which is just a global fall-through. If you didn't match against any of the above, hit this, and then we're going to return just our state object, because this isn't a recognized action, which is what we run, right? That's what our previous JavaScript file was doing. So we're pretty close. Finally, we need to handle the undefined state case and return the initial state when the reducer is initialized. This is harder than it looks in Reason. The reason why is that Reason has no concept of undefined or null, which is great because in a pure Reason application, you cannot get null pointer exceptions or anything like that. However, we need to handle this case. And to handle this, we need to learn a little bit more about variant types in Reason. So a variant type, to a lot of us, will look at pretty similar to an enum. So if you look at the top left, my response variant, you can just assign these labels, much like an enum, but they come as a group. So the my response variant type can be any one of those three, yes, no, pretty much. And then we can assign one of those labels into a variable. So much like an enum that we'd recognize from other languages. But these sort of enums pair quite nicely with switch statements. So we can run a switch against that variable and then run through each of those variants that come as a group and do something different, return something different, because a switch statement is an expression, depending on which one we see. But variants are a bit more powerful in that they're not just like a normal enum, they can also wrap data, which is a little bit strange. And for some of us, that might be similar to think of a bit more just like a class. In fact, they're also called variant constructors when they take data, right? But it's just much simpler and a bit more different powers than a class would. So we can annotate that type like above by just passing other types into our variant. So we've got none that takes nothing. Instagram might take one string. Facebook here will take a string and an integer. And to create these types and store them in a variable, we'll just pass our data into them. So we've got Facebook, string, integer, Instagram, just somebody's name, one string. And then this can also work through the pattern matching system. So when we run a switch statement against that variable, we can then handle each case, but take the data into our switch statement and use it, which is really, really useful. So you can see in none, we have no data to play with, so we're just going to say hi. In Instagram at the bottom, we've got one string, a name, that we're going to pull out of the variant and use in our return string, hello name, and similar for Facebook with those two arguments. So suddenly we can analyze a variable as long as it's annotated with one of these variant types and do quite different things with it, depending on what it is. So the best way to handle null or undefined in a JavaScript file is not to use like an if statement or something and try and cast the state variable to a Boolean. I think you can do that, but it's a bit messy. The more idiomatic way of doing this would be to use the variant system. And luckily, Bucklescript gives us a system just like this. So you can see on line 12, we're taking that state and passing it into a function called js.nullable.toOpt. Option is a variant that is built into Reason. We don't need to define it. And the option type contains two variants, sum and none. None wraps no data, sum wraps whatever data that you give it. This function will cast our state variable into one of those variants, and then we can run a switch statement against it. So you can see we've now nested our switch statement. We've got another one around it. This one checks for none, and if it sees none, then it will return initial state, just like we want. And if it sees something, it will take whatever that thing is from the sum variant and run the next switch statement through it. And now, using that, we can check for null or undefined in the kind of the reason way. The advantage of this is that the compiler knows all about those groups of variants that we see. And if we're checking for one, it needs to make sure that we're checking for all of them. So if we were to miss out the none check, for example, we're going to see something like this. You forgot to handle a possible value here, for example, none. So the compiler knows that sum and none came together. And if we're handling one, we must handle the other. So you can much, much easier have checks for edge cases in this way. Obviously, in this file, we've only got one reason file in the whole project, and we need to cast that variable to a variant. But in a larger project, as you add more and more reason into your project, these variant types could be coming from anywhere, and this state could be passed to you as a variant already, and you just need to check for it, and the compiler will force you to check for all of the cases. OK, so now we should have an output that works pretty well. It looks pretty much like we want it to. But what we'd really like is for that compiler power with the variant system to check against our action names as well. We have an expressive type system now, so we can use it instead of using strings all over our JavaScript to check for cases. This is a little bit tricky as well, because obviously the JavaScript that we're integrating with uses these strings. So the best way I could find was to kind of create a bit of an adapter for our reason file. I was digging around in the source code for the bindings for fetch, the reason bindings for fetch, and I saw something along these lines. So you have an action type. Well, I called it action. It was completely different in fetch, obviously. But you can define a variant with all of your situations, and then just have two functions like decode and encode to switch between the string to the variant or the variant to the string if you're going back into your JavaScript. So as long as we run our action type through one of these functions, we can get a variant type back, and that variant type will be grouped with all of the others. So we'll get compiler checks. Not for free, but almost for free. The last thing is, if we don't recognize this action string, then it will fall through to the other type, and then that other's just going to hold on to that action string so we can do something with it if we want, like print out an error. So once we've done this, we can have code that looks a bit like this. We need to open up the file that we just made. I called it actions_re. There's definitely a better way of naming it that. I just wanted it next to the actions itself as an adapter in the file tree. And then we pass our action type on line 15 to that decode action type function, and we get a variant back. And then we can use our switch statement against that. Now, if we were to miss out any of those action handlers, like request top stories, again, we get a compiler error or warning. You forgot to handle a possible value here, for example, request top stories. And suddenly, this gets quite powerful. The compiler is checking that we've handled all of the cases for the actions in our application. So we've gained some stuff out of Reason. We can refactor this a little bit further if we want to. One of the powers of a switch statement is it can actually do a switch on multiple values at once. So if you hate nesting, you can do this and switch on option state and action type at the same time, and then have a flat set of statements checking against each one. So we've got like some action name, some other, or none. In this situation for reducer, there's going to be so many cases under some. I think actually the nesting's fine, but this is an option if you want to do it. And then we've got our reducer file, and then we can include it. The standard way of including a reason file would actually be in a lot of the examples that you see, just including the JavaScript directly from the folder where everything's compiled to, which looks quite strange. So you can actually reach straight up into lib.js source reducer.js, which is the file that the Bucklescript compiler created when reading reducer.re, and pull that in, which is fine because the Bucklescript compiler is going to run first, and then the Webpack bundler is going to run second and pull everything together. It just looks a bit weird. So what do we do when something looks weird in our code? We pave over it with a Webpack plugin. Hooray! So one of the options that we have is to include Bucklescript loader. Much like, again, like we'd do with TypeScript or something else, if Webpack sees a file that it doesn't recognize, we can have a loader for it. So in this case, we're checking for a .re file or a .ml file, which would be an OCaml file, which Bucklescript loader can handle as well, because Bucklescript can handle both. And in this case, we're showing that the module is going to be, we want it to output an ES6 module. I forgot to mention, if I go back quickly, that one thing we added to the end of our reducer was this let default equals reducer. As long as we're exporting a variable called default, and we're compiling to ES6, then we can import it into another ES6 file without having to worry about picking a particular file name. So it allows us to do this, import reducer from reducer.re, which is quite nice. Much, much simpler. It also has the advantage that because everything's handled by Webpack, we only would need to run one command when we're building our app, which would just be Webpack. I found in practice that the compiler output and the warnings were slightly easier to read directly from the Bucklescript compiler, so I still ended up running both, just for ease of reading errors. So we've added Reason directly back into our app. So what have we gained? Well, it's hard to mess up our state shape because we have a strong typing system. So if on one of our action handlers we returned a state that looked a little bit different from the others, the compiler is going to complain. It's going to shout at us. The state of the shape needs to stay the same. It's hard to forget to handle actions because if we're wrapping our action strings in variant types properly, then the compiler is going to shout at us if we don't handle all of the cases properly. And it's hard to forget to handle edge cases, because if we're using option types, which is almost hard not to do, then the compiler is going to shout at us if we're not handling the edge cases. So these three things are almost the most important functionality of a reducer, right? Don't mess up your state, handle all of the actions that you need to handle, and handle your edge cases. And now these are all checked by the compiler before the code will even build and before your unit tests are even going to run. So we've actually gained quite a bit here. And that's all I've got planned for because we don't have a huge amount of time. What we haven't covered, which is kind of insane for a talk about React and JavaScript interop, is the Reason React API. We didn't even look at that header component. This is what it looks like. The Reason React API is pretty simple. In order to define a component, you actually use object spread syntax, which is quite nice. But there's a load of more stuff about, obviously how you handle state updates, that new Redux-style action handling system built right into the components. But again, you can see all of that in documentation, right? And another pretty important thing, importing JavaScript into Reason. Bucklescript has lots of methods to do this, like this bs.val. Annotation. Again, you can find that in the documentation. It's not too special. They're a little bit tricky to work with, but you just need to try them out. So hopefully that's a kind of a quick run through why not only is Reason really easy to integrate into your application, but why it can really actually provide you some value. There's a lot of really clever, interesting systems built into Reason that come straight from the world of functional programming, like algebraic data types, that you can use to make your applications much, much more robust. And you can really do that today. If you want to find out more, this project I dumped on GitHub. I think there's a lot of good stuff in there. Obviously, this language is still quite young. There's still documentation to write. There's little things in there that took me a while to find, like running unit tests in Reason with the jest Bucklescript bindings. I'm on Twitter if you want to talk to me, but I'm not an expert. But also the Discord channel I found really, really helpful. There's a very strong community on Discord, on the ReasonML channel. I posted in there with a problem. I got a reply from the great Cheng Lu himself, and he was really, really helpful. And also, if you want to contribute to the project, now is absolutely a good time. There's a really, really good page on the ReasonML documentation called Examples, and it's designed for newbies like all of us, or no, actually like me, maybe not you, that is lots and lots of examples of like common pitfalls and things that you might find hard to find when you're writing your files. So I contributed to that page when I was writing this talk with the stuff about the option type in JavaScript. If you're digging into Reason, I really, really encourage you to find anything that you find difficult and you find a solution for, contribute to the docs. Like, it's not too early at all to contribute to the project. It'll be really, really useful. So hope you found that inspiring. Thank you very much. Any questions? Damn, there's one.
Moving over to Reason, have you found any really big pain points, like anything really big?
There were a couple. I mean, so learning some of this Reason made me feel really dumb, but kind of in a good way, like in a healthy way that learning a new language does, because you're learning new concepts. One of them was handling that undefined case when you get a JavaScript variable that's undefined or null. That was quite hard to find, and I had to dig through a lot of like the documentation of the Bucklescript compiler to find that. And that is just, it's quite an obvious thing that's very obvious to the people that made Reason, obviously. That's like really good to put on that page. The other thing that's quite painful in Reason at the moment, which I haven't played with much, is parsing JSON. So in a lot of example projects that you'll see, you'll see quite a lot of code for handling API responses. And it's just because we need to pull that JSON in, parse each bit, and annotate all of the fields that we're interested with a type, and handle all of the cases when it doesn't look like that. That is being worked on. It's listed on the sort of next steps on the Reason website, and there's a pull request up on the GitHub repo right now. Those are kind of the two things that really screwed me over, but there will be many more in the future, I'm sure. It is a young language, and felt a bit weird. It felt a bit like a failure having to go to the Discord channel. And I thought there must be documentation out there. Why do I have to ask a question? I think we're still at the stage just about where if you're an idiot like me, you need to ask on Discord. But the documentation's still much better than I thought it would be. So those are the 2 pain points I noticed.
Thank you.
No worries. Awesome. OK. Yeah, go on, Stu. Turn on your microphone first.
Hello?
Hi.
So I'm convinced that within a year, this is going to take off massively Reason, and we'll be all writing our React apps in Reason, especially when WebAssembly becomes a viable compilation target. So given that that's a goal,
yeah,
and you start incorporating Reason into your application like you've described, using all the JavaScript sort of Bucklescript niceties that gives you the right output. At what point can you then go to sort of drop the JavaScript stuff and go to native ReasonML data types?
I'm glad you asked that. Not planned, because I forgot to mention a lot of the example projects you see are a little bit more advanced than my example in that they have a lot of adapter layers. So on the sort of the point between the JavaScript and the ReasonML, there'll be an adapter which will convert from the fuzzy, messy, mutable JavaScript objects to proper Reason records, or proper Reason lists rather than arrays. And then you get, whilst you're in Reason world, you get all of the optimizations and stuff like that. So I think that the proper way to do it would be to create those adapters and gradually move them through your code base as you write more Reason. And I didn't have time to figure that out. But yeah, I think that's what you should do. Otherwise, yeah, it would just be a mess of JavaScript types that you've got to go and clean up afterwards. I think that's the way. Cool. All right, thank you, everyone.